Problem 14 asks us to investigate the chemistry side of exponential functions a little bit, this time in terms of half-life. And we have an exponential equation that's given to you. A equals P times 1/2 to the T over K. Let's talk a little bit about what these different parameters mean. Just like in any financial problem, A is going to be the final amount that you have. P is going to be how much you start with. Your 1/2, this is about half-lives, so that's going to be what's going to drive this thing to be a decay. So let's call that the decay function. T, this problem appears to be in years, so T is going to be time in years, and K is going to be our half-life. In fact, in the first part of this problem, it tells us that mathogen, which totally is a real element, I swear, mathogen has a half-life of 57 years. And I have 500 kilograms now. We could put those in to our formula as we go. We're going to start with A, our final, we don't know that yet, equals 500 times 1/2. We don't know our time yet, so we have T, and our half-life is going to be 57. Part A asks us to plug in 40 years for T and give us some kind of answer. So if we have A equals 500 times 1/2 to the 40 divided by 57. I could actually plug this entire thing into my calculator and be done with it. So 500 times 1/2, I'm going to use parentheses a lot on here so I don't accidentally screw up order of operations. Remember that you are much smarter than your calculator and can deal with things being in the wrong place. Your calculator cannot. So I have 500 times 1/2 in parentheses raised to the, and I'm going to use parentheses and just do 40 divided by 57. So again, that's 500 times parentheses 1/2 close parentheses. I use the caret symbol for the power, open parentheses, 40 divided by 57 close parentheses. And when I press enter, it's going to give me my value for A, which in this case is going to be 307.41. And we're in kilograms. This means after 40 years, we're going to have 307.41 kilograms. The second part of this question asks us how long will it be, so it looks like we're solving for time here, before you have 300 kilograms. If we have 300 kilograms, that's probably going to be our final value. That's pretty close to what we had before, so it'd be a good bet that our time is going to be pretty close to 40 years. It's useful to estimate things before you solve them to see if you're on the right track. If I plug this in, 300 equals 500 1/2 T divided by 57. The first thing I might want to do is get the exponential part by itself. And for that, I'm going to have 3 over 5. I divide both sides by 500. Equals 1/2 to the t divided by 57 power. Okay. 1/2 is a non-standard log base. This is going to make it a little bit more difficult for us to choose a log base that's going to be useful. So what I might do is just take the natural log of both sides. And here's why. If I do the natural log of 3/5, I'm going to get an answer. Which is negative 0.51. Let's go 511 so we have 3 decimals. On this side I have an exponent that I can bring down, which is really going to be nice. So it's going to be t over 57 times ln of 1/2, which I can also figure out. ln of 1/2 is going to be negative 0.693. Okay, now it's a matter of solving for our t. Let's get rid of those negative decimals. So I got negative 0.511 divided by negative 0.693. Leaves me with 0.737. .737 equals t divided by 57. If I multiply both sides by 57, I'm going to get a result of t equals 42.03. So that means that after 42.03 years, I'm going to have 300 kilograms remaining. That also jives with our first estimate that it would be pretty close to 40 years. So we're in pretty good shape.